Good afternoon, looking at lesson 15. So we're going to start getting into a little bit of stuff from pre-calc that you're going to need if you continue on. The first part is stuff that we would have covered in Algebra 2, but after that I'm going to start getting into some pre-calc information. All right, so let's take a look here. This first diagram is something that we've already talked about when I first introduced the unit circle and sine and cosine to you guys. But we're going to talk about what's called the Pythagorean identities. Obviously, Pythagorean means Pythagoras, the Pythagorean theorem, and that's part of it. What is an identity? An identity is just a statement of equality, is what that is. So it's just stating that things are equal to each other. All right, so let's take a look at this picture of the unit circle. The unit circle obviously has a radius of 1. We talked about how this distance from here to here would be a distance of x, and this height right here would be y if this is some random coordinate xy. We have a right triangle here, and if you use the Pythagorean theorem, a squared plus b squared equals c squared, if you plug your x and y in for a and b, you get x squared plus y squared equals 1 squared, which of course just becomes x squared plus y squared equals 1, because 1 squared is just 1. But remember, when you're on the unit circle, x is cosine and y is sine. So I can replace this x with a cosine, and I'm going to use theta, because theta is the common letter that's used in trig. Cosine squared plus sine squared equals 1. So I've replaced the x with cosine, I replaced the y with sine to come up with our first Pythagorean identity. Now it can be written like this, but you also might see it written like this. Cosine squared plus sine squared equals 1, like that, or you could have it in parentheses with the squared outside. That right there is our first Pythagorean identity. That is definitely something we would have covered in Algebra 2 had we been in school this year. We're going to build on that and use it for more stuff that we're going to do that's pre-calculated. But for now, I just want to show you a couple of examples of how you use this to get some answers. All right, so here's our first example problem. We have some information given to us. We're told that the cosine of b is radical 5 over 3. We're told that angle B is in quadrant 3, and we want to know the sine of b. Now, instead of drawing a diagram like we did in the previous stuff, we're going to use this new Pythagorean identity to get our answer instead. It's just another way that you can solve these types of questions. So let's first write down our Pythagorean identity. We have cos squared, it's angle B this time, so I'm going to call it B. Cos squared B plus sine squared B equals 1. So that's our Pythagorean identity. So what do we know? Well, we know that the cosine of B is radical 5 over 3. So I could put that in right here. Radical 5 over 3 squared plus sine squared equals 1. So I'm going to use this to help me find the sine of b. All right, so what happens when I square radical 5 over 3? Well, that just means I take radical 5 over 3 and multiply it by itself. And radical 5 times radical 5 is radical 25, which really just turns into 5. And 3 times 3 is 9. So this turns into 5/9. So 5/9 plus sine squared b equals 1. I'm trying to solve for sine squared b. So I need to move this 5/9 over to the other side by subtracting it. So I'm going to subtract 5/9 from both sides. And that's going to leave me with sine squared b equals... Now what happens when I take 1 minus 5/9? If you think of 1 as 9/9, so you have common denominators, 9/9 minus 5/9 is 4/9. All right, if you want to try that on the calculator, you can do that. Just do 1 minus 5/9 on your calculator, and that'll also give you 4/9. But I'm treating 1 as 9/9 minus 5/9 and calling it 4/9, doing it that way with common denominators. When I get to here, I now need to square root both sides, and that's going to leave me with the sine of b. When I square root 4/9, that's the same as square rooting the top and the bottom. So the square root of 4 is 2 and the square root of 9 is 3. So it's going to leave me with 2/3. But now I got to go back to this right here. We were in quadrant 3. So when you go to quadrant 3, which is the t quadrant, sine is negative in the t quadrant. So I need to make sure that I put a negative on my answer. So call it -2/3. So there's an example of our first time using this Pythagorean identity right here. Cosine squared plus sine squared equals 1. Okay, so here's where the pre-calc portion comes in. So we can take this equation and we can manipulate it and do some things to it to make it a little bit different. So if I wanted to take this equation right here and divide everything by cosine squared, which I'm allowed to do because whatever you do to one side of the equation, you must do to the other. So I'm just dividing everything by cosine squared. If I do that and reduce this out, let's see what happens here. Cosine squared over cosine squared, anything over itself just becomes 1. Sine squared over cosine squared. Well, we know that sine over cosine is tangent. We learned that a while ago. So what's sine squared over cosine squared going to be? That's going to be tangent squared, because it's just squared now. So this is going to be tangent squared. And 1 over cosine squared. Well, 1 over cosine is secant, because secant is reciprocals with cosine. So 1 over cosine is secant. So 1 over cosine squared is going to be secant squared. So there is our second Pythagorean identity right there. 1 plus tangent squared equals secant squared. That is new. That's something that even if you took skills with me or last semester, you haven't seen before. This is our second Pythagorean identity that we can use to solve other things. So let me show you an example of that. All right, so here's an example of using that second Pythagorean identity. I have it written up here. 1 plus tan squared equals secant squared. In this problem, I'm giving you that the secant of some angle A is -3, and we're told that angle A is in quadrant 3. What is the tangent of A? So we're just going to plug into this equation and get our information. So we have 1 plus tan squared. Well, I'm going to use A there, tangent squared of A, because we're talking about angle A in this problem, equals the secant squared. So we're told that the secant is -3, so this is going to be -3 squared right here. We're trying to find tangent, so we're going to leave that as tangent. When I square -3, I get 9. So I have 1 plus tan squared A equals 9. If I subtract the 1 over to the other side, I get tan squared A equals 8. And then I square root both sides and get that the tangent of A is radical 8, which you could reduce. You can simplify that radical if you want to 2 radical 2, but we're fine. We can leave it as radical 8. But we need to establish whether that answer is positive or negative, and that, of course, goes back to this information right here. The angle A is in quadrant 3. Quadrant 3, 1, 2, 3. That's the T quadrant where tangent's positive. And this is a tangent answer right here. So we're going to keep that as positive radical 8. So there's another example of how you can use these Pythagorean identities to help you get information other than drawing the triangles like we did previously. So I have my original Pythagorean identity drawn back up here again. Cosine squared plus sine squared equals 1. I want to show you that there's one more manipulation we can do to it. We can take this equation and divide everything by sine squared to create a third Pythagorean identity. So cosine over sine. All right, what is that? Well, let's take a side note for a second here. We know that tangent is sine over cosine. We learned that a while ago. If I flip that and I flip this and do the reciprocal, that means that cotangent is cosine over sine. So if I have a cosine over sine, I'm actually talking about cotangent. So that right there turns into cotangent squared. So I'm going to replace that with cotangent squared. Sine squared over sine squared is just going to reduce to 1. And then 1 over sine, we know that that is cosecant, because cosecant and sine are reciprocals of each other. So that is actually cosecant squared. And there is our third Pythagorean identity that we can use. So if you have a question where you're given the cosecant and you need the cotangent, or you're given the cotangent and you need the cosecant, you can use this third one. So those are the 3 Pythagorean identities. They're all based off of that first original one, and you can use those to solve and find missing parts that you need.